Hello and welcome to Extending ArcGIS Enterprise, Developer Technologies and Webhooks. My name is Joel and I'm joined here today with Han and Pankaj. And we are going to be sharing with you some of the cool capabilities in the ArcGIS Enterprise platform that allow you to extend some of those out-of-box capabilities further. I'll begin by covering webhooks with you, going over some of the key terms and sharing a demo. And then Han and Pankaj will dive into server object interceptors and server object extensions. And they have some really great demos prepared for you. So let's begin with webhooks. So I always like to start off by conceptualizing what a webhook is by using a real world example. And so we're going to take Google Flights for this case. So let's say you want to track a flight because you want to try to buy a ticket at its cheapest point. One way you can do this is you can continuously revisit a site like Expedia or Travelocity and keep visiting the site to see if the price of the ticket has changed. Sometimes you might go into incognito mode because you bought into some of those conspiracy theories. Don't worry, I have too. Google Flights has a great feature called flight tracking that allows you to subscribe to a flight and be notified via email anytime the price of that flight increases or decreases. And this is essentially what a webhook is. Instead of having to continuously revisit Google Flights to check on a flight, you can just have Google Flights notify you when the price of that flight has changed. All right, so now that we have an idea of what a webhook is, in ArcGIS Enterprise, this is a capability we introduce to allow you to automatically provide other applications with event-driven information that would be delivered as an HTTPS request via post. You can use webhooks to create automated and integrative workflows, adding new extensibility to ArcGIS Enterprise. So let's look at an example of what this looks like inside of the ArcGIS Enterprise portal. So we have our users interacting with the ArcGIS Enterprise portal. They're adding items, they're creating groups, they're sharing items to other users. And let's say as an administrator, we want to be notified when one of these events happens. I can create a webhook in the ArcGIS Enterprise portal that is specifically subscribed to one of those events. Let's say I want to be notified anytime a user adds a new item. And so our user adds an item, our webhook is triggered, and a payload is sent out to a pre-configured webhook receiver that we can then use for post-processing that information, maybe for operational intelligence, or to integrate with some of our other systems. And later on, I'll share with you a demo to see all of this in action. So what are the advantages of using webhooks? If we take that first example of Google Flights, it's more efficient than polling. You don't have to keep asking the server for information. Instead, the server will tell you when it has information for you. And that allows you to create custom event-driven workflows that you can then integrate across multiple systems. And this webhooks allow you to create new and more efficient opportunities for automation. I'm now going to share with you some of the key terms associated with webhooks, and the first one is trigger event. So this is the operation you set to trigger your webhook. For example, you can configure your webhook to be triggered when a specific item is updated in ArcGIS Enterprise or when an item is shared. And a webhook can have more than one trigger event. So here we have all of the trigger events pertaining to items in the ArcGIS Enterprise portal. So if we start at the top, we have /items, and this essentially gives us all of the events pertaining to all of the items in your organization. But you can narrow it down by using the operation or by specifying a specific item ID. Similarly, you can do the same for events pertaining to the users. So here we have /users, and this will give you all of the events listed below for all of the users in your organization. Or if you're only interested in subscribing to an event pertaining to a specific user, you can use their username to do so. And we also have events related to the groups. So you might be interested to know when a user is added to a specific group. Maybe it's a group linked to your distributed collaboration, and only certain members of your organization should have access to that. So if we look at the bottom row, we have /groups/group ID add users. So that event is triggered when a new user is added to that specific group. And in ArcGIS Enterprise 10.8, we added some new trigger events pertaining to user roles and license types. So as an administrator, you now have the ability to be notified if a user's role is updated or their license type is changed. Next, we have the payload. So once a webhook is triggered, a payload is delivered to a specified payload URL in JSON format. And each event follows a similar JSON schema with information that is relevant to the event. So if we work through this payload, first we have some high-level information about the webhook. So this is telling us the portal that the webhook was created in, the name of the webhook, and when the payload was sent out. Then we have some information about the events. So first, we're told that this is an item that was shared, and we have the item ID. Then we have some information about who shared that item, and so there we have their user ID as well as their username. And then we have some additional properties. So here we can see that the item was shared to everyone, so to the public, and to a specific group, which is indicated by the group ID. And finally, we have the payload URL. So a payload URL must be provided when creating a webhook, and as this defines where the payload will be delivered. Since all payloads are delivered through an HTTPS post request, the webhook receiver must be configured to communicate over HTTPS and be reachable by the portal. There are a number of options for how and where a webhook is received. You can use third-party receivers such as Microsoft Power Automate, Zapier, Integromat, or you can use a custom web server. We've included a Java servlet in the Enterprise SDK samples. You can also create a Node.js script or a Python Flask application. Okay, so what can I do with this? Let's look at a demo. Okay, so here I have my ArcGIS Enterprise portal. To create a webhook, we're going to begin by navigating to the sharing API. So in the URL, after your web adapter, just put in sharing/rest. And I'm going to log in as an administrator of the ArcGIS Enterprise portal. Next, I'm going to click on my org ID. And if I scroll to the bottom, under child resources, you'll see webhooks. So here we'll list all of the webhooks configured with your organization. And so we already have one configured, but let's create a new one. So I'll begin by giving my webhook a name. Let's just use webhook example. Next, I need to provide a payload URL. I'll come back to this shortly. Here we can add a secret. And so this is a secret that you can put in your payload so that you can verify the authenticity of where it's being sent from. You can also configure some properties with your webhook. So how many times will you attempt to send a payload before the webhook is deactivated? And then finally, we can specify which events we want to trigger the webhook. So let's use /users for this example. And so we'll receive all events for all users in our organization. So for the payload URL, I have a Node.js application that I'm going to run. And this is going to act as my webhook receiver. So I'm just going to open up my command prompt. And here is my payload URL. I'm going to copy that and paste it into here. And so that's it. Once I hit create webhook, our webhook should be created. If I go back to my payload URL, I'll see that I received a request confirming that the webhook was created. Now let's look at an example of what that payload looks like when an event is triggered. So we'll navigate back to the organization's homepage. Because we've set up a webhook that's subscribed to all events pertaining to all users in our organization, when I sign in, I should see that the webhook is triggered based on the sign-in event. And there it is. And so if we come to our Node.js application, we can see the payload, and it's telling us that this user signed in at this time. And apparently I've also exceeded the number of licenses assigned to me in my organization. So that was a very simple example of how to create a webhook and what the payload looks like. But you can also create more complex workflows and integrate with third-party applications such as Power Automate. So here we have all of our events being sent to this post URL. And as those events come in, they are being added to a data set that is powering a live dashboard in Microsoft's Power BI. We have a lot of great resources out there to help you get started with webhooks. Here is our help documentation that walks through all of the terms I covered today. You'll see all of the trigger events listed here. We have an example of what the payload schema looks like, as well as steps for creating the webhook. Also, we've created this page on GitHub. It's github.com/esri/webhooks-samples. And here we have a lot of great samples, such as the Node.js application you saw me using earlier, a Python Flask example, and as well as a Java servlet. And so I would recommend, if you're interested in creating your own payload URL, to come check out this page. You might have noticed that most of the events we are supporting right now pertain to ArcGIS Enterprise administrator workflows. We know there is a lot of interest in supporting feature service editing events, such as getting a notification when a new feature is added, edited, or deleted. So that is something we are actively working on, as well as the ArcGIS Online team is actively working on, and we are hoping to have ready sometime in the near future. Okay, so that's it for webhooks. I'm now going to pass it on to Han and Pankaj to talk to you about SOIs and SOEs.
Thank you, Joe. Next, I will go through the SOI and SOE part with my colleague, Pankaj. So let's talk about SOI first. How does an SOI work? Before we answer this question, we need to understand the server-client model. This diagram demonstrates a very typical server-client model. Starting from the server side, assume we have a map service here. This service can have multiple service instances running, and each service instance is powered by a server object running as an arcsoc.exe process. In terms of the client side, the client applications that are used to consume this map service can be of different types, such as a mobile app, a JavaScript web application, or even a desktop application. When a client sends a request to the server, it reaches to the server object, and the server object will perform corresponding operations based on the request URL and the request parameters, and then generate a response. The response can be a status code indicating whether this operation succeeds, or it can be some data content, such as a JSON query result or an export map image. Then, the client application receives this response and renders it to the end user. So this finishes one request-response cycle. Next, let's add an SOI to this map service. We can see the SOI sits on the server side, on top of the server object. When a request comes through, it no longer reaches the server object first, and instead, the request is sent to the SOI first. So at this point, the SOI can decide whether or not to modify the request parameters, and then the SOI will pass the request to the server object for processing. After the server object has a response ready, it sends the response to SOI again, and this would give the SOI another chance to modify the response. After that, the SOI will pass the response back to the client. So basically, an SOI can modify both the request and the response. And of course, the SOI can also let through the request or the response without any modification. From this diagram, we can see why an SOI is called a Server Object Interceptor, because it intercepts the traffic between the server object and the outside client. Now, we're ready to face the real world. Let's look at how an SOI can be used to solve real business problems. The first use case for SOI is logging, auditing, and metering. This is the simplest scenario because in this scenario, the SOI is not modifying any request or response. All the SOI does is to log messages when certain operation is performed. So for example, when a service operation is requested by an end user, the SOI will log a message in server logs to record which user performs what operation at what time. And this will help the enterprise administrator to monitor or audit their users' activities. And if they have their own logging mechanisms, such as a log database, they can write logs to the database from their SOI too. Another point worth mentioning is that, based on the SOI logs, we can get the end user's usage of a certain service and charge the end user for the service usage. And this metering function is used more often among GIS service providers. The next use case is fine-grained user access control. Since SOI is able to obtain the current login user's identity and group information for each request, we can use an SOI to limit which user or which group the user belongs to can access certain layers, fields, or even records. Pankaj will show a demo for this use case later, so we will skip it for now. SOI can also be used for lots of data manipulation tasks. Let's start from data validation. Data validation usually happens when we pre-process requests from an SOI. Here is an example of using SOI to validate add features operation. Assume I have some new features to add through my feature service. But before sending those features JSON to the server object, I can use an SOI to check whether all the features have valid attributes and geometry. And my SOI can reject unqualified features and only pass those qualified features to the server object for processing. In other words, only those features that meet my criteria can be added through my feature service. The next use case is data filtering and data enrichment. The watermark function actually falls under the category of data enrichment. Data enrichment usually happens when we post-process response. Here's an example of a query response. The content of a query response is usually a feature collection in JSON or GeoJSON format. When this feature collection is generated by the server object and sent to the SOI, the SOI can pull some extra data from an external data source to integrate this extra data into my feature collection. And this will enrich the query response. At the same time, the SOI can also filter certain information from the query response. And in this way, the client application will receive the enriched and filtered query response. Another data enrichment use case, as I mentioned earlier, is to add a watermark for export map operation. So when every time a map service is rendered, it will always show your own watermark on the map. And this works regardless of what types of client application you use to render the map service. So now I will hand over this part to Pankaj for an SOI demo.
Thanks, Anhan. Main objective of this demo is to show how you can restrict the access to the layers and data available in map service using Server Object Interceptor. Here, I have already built a system called Cherry Tree National Park. This is a dummy national park system which I have completely made it up. Don't try to search it on Google, you won't find anything about this. Here, I have categorized the user who are using this system under these three core groups. The first is visitor services group. Teams like park rangers, tour guide, transportation services falls under this group. Next is maintenance services. Teams responsible for daily or routine maintenance of various sites within national park falls under this group. And lastly, emergency services. System administrator, law enforcement officers, security officers, medical or healthcare officers, etc. falls under this group. So here for each group I have assigned multiple users, and this is my system and this is my data. Here I have park boundary layer, then subdivision. Entire park is divided into 3 subdivisions. Then each subdivision has maintenance sites which needs a routine maintenance. Then I have roads, streams and walking trails. I have published this entire data as a single map service using ArcGIS Pro. And this is my map service. As you can see, it has exact same layers. Here, as the GIS administrator of the system, what I have done is I have restricted access to layers and data depending upon the user who is accessing map service with the help of Server Object Interceptor. Let me demonstrate this to you. Here I have already logged in as one of the user from emergency services group, and being a emergency services, this user group has access to all the layers. Let's check this in web map viewer. Yeah, as you can see, this user has access to the entire data. Here I have logged in as one of the user from visitor services group. As you can see, this user can view only his own group information. This user group has access to trail, roads and park boundary layer. Let's verify this in web map viewer. Yeah, as you can see, this user has access to only these 3 layers. Now here I have already logged in as one of the users from maintenance services group. This user has access to roads, maintenance sites, subdivisions and park boundaries. Here I have an additional condition. This user group shall be able to view only the maintenance sites and subdivisions assigned to them. They won't be able to view other subdivisions and maintenance sites. So let's verify this behavior in web map viewer. Here, as you can see, this user has access to all these 4 required layers. But if you have observed carefully, this user can view only a subdivision and maintenance sites assigned to him. He is not able to view the other subdivisions and maintenance sites. Correct? So what's happening here is essentially server object interceptor is intercepting the incoming request before it goes to a map server object, rewrite the request depending upon the user who has logged in, and then sends the modified request back to the map server. Then it receives the response from the map servers and send this response back to the client. Interceptors are great because we don't have to write a custom application to use it. Like here, this is an ordinary map viewer who does not know that there is some sort of interception logic running on server. Technically, you can use this map service in any ArcGIS client and you will observe the same access control behavior. Now, let me show you how I have developed the interceptor for this demo. On my machine, I have installed Enterprise SDK because I am developing an interceptor which works on map service published from ArcGIS Pro. But if you are planning to develop an extension or interceptor which must work on map service published using ArcGIS Desktop, then you should use ArcObjects SDK. Hanan will explain these two SDKs and their use cases in further part of the presentation. Once you install the SDK, it configures the template in Visual Studio for .NET based development and provides an Eclipse plugin to facilitate the Java based development. SDK also lays down a sample which are good starting point for you to quickly get started with the development of interceptors and extensions. So here I am starting with Eclipse IDE. I have already configured the Enterprise SDK plugin in this IDE. I have created an empty Java project. As you can see, there is no class. Okay, now let's start writing a interceptor. Right click your project directory, new, go to the others. Here you can see ESRI template section because I have already registered Enterprise SDK plugin in this IDE. Then navigate to the server. Here I'm starting with this template because I'm interested in writing an interceptor which works on map service published using ArcGIS Pro. Click on next, enter some package name. Then you can specify a meaningful name for your interceptor, display name and description. Once you click on finish, it will add a custom interceptor class in your empty Java project. So this is my pre-written code and I have started with the same template. As you can see, this template provides a lot of boilerplate code. It basically stubs out all the functions for you. Then you can slowly visit the required functions to write your custom business logic. And because of this, we strongly recommend you to start with these templates. Now here you may say that your favorite choice of IDE is not Eclipse. It could be IntelliJ or NetBeans or something else. Then in that case, you can still start with Eclipse, configure the SDK plugin, create empty Java project, add the required interceptor or extension class. Then zip up this project and open it in IDE of your choice. Later, once your coding job is done, you can use the command line tools for exporting the extensions. Okay. Just to let you know, we are working on building seamless user experience for creating extensions across multiple Java IDEs. Hanan will talk about it in further part of the presentation. Let's come back to our project. Here I have started with the SOI template. As you can see, it's annotated as interceptor true. Entry point is map service. And this is my custom interceptor class. And this class implements these interfaces. Implementing all these interfaces is a prerequisite for Server Object Interceptor because map server object implements all these interfaces. This iREST request handler interface is used to intercept the REST requests. iWeb request handler interface is used to intercept the OGC request, and iRequest handler interfaces are used to intercept the SOAP request. Okay. Then next is init method. This is a place where you shall write your initialization logic. For example, if you have an integration with third-party database, then you can establish your database connection here. One important point to note here is code in this method will run only one time. That is when the service starts. For this demo, what I'm doing here is I'm reading the permission information from my database, and my database is in form of JSON string. So here, as you can see, I have specified the user groups, layers accessible for user groups in the form of layer index, and authorize data restrictions if applicable by providing the appropriate layer index and restrictions in the form of definition query. Okay, so I mean for this demo I'm using this particular JSON string as a dummy database, but in real applications this information can come from RDBMS or authentication systems like Active Directory. Okay, next I'm interested in intercepting the REST request. So as names, so I need to write my custom business logic in this particular function. As name suggests, handle REST request. This function handles the REST request. This function will get invoked every time a REST map server request is made to your map service. If you look at this payload, mm, it looks very much like a REST request. Okay. So in this function, what I'm doing is I'm adding few messages for my logging and auditing purpose. Then here I'm retrieving the information about the user. So here basically I'm retrieving the user group, and then I'm query based on that user group. I'm querying the information from my database, like what are the authorized layers accessible for that user group, and if applicable, is there any authorized data restrictions. Then whenever you access a map service in any client, it's nothing but an export map API call. So here we are checking what is the input operation. If it's an export map operation, then we are modifying those two input parameters of the incoming request. The first one is layers. Here we are modifying this layer parameter to show only the access layers accessible, and we are also modifying this layer def parameter to show the restricted data if applicable. Got it? So that's all change I have to do in this particular function. So once you modify your incoming request, then the request goes to the map server, and you will get the response back from map server. Yeah, so this is a place where you get the response back from map server. So again here you have an opportunity to intercept this response for post processing. For example, let's say if you want to add watermark, or you may want to annotate your map with something else, then you can write your piece of code in this particular place. We already have one sample for watermark. You can refer to that sample. There we have explained how to intercept the outgoing response. Okay, so that's all. This is all about my code. Essentially what I did is I have established my database connection in this init method, and I have modified this handle REST request function since I'm interested in handling the REST request. Okay, then next part is export your extension. So right click your project directory, ArcGIS, go to export SOEs and SOI. Here I'm seeing all these options because I'm reiterating it again because I have configured the enterprise SDK plugin with this ID. Okay, so here I have to choose my extension class. Yeah, and you have to note down this path and click on finish. So if you have seen, the moment I export the extension from ID, it creates one .soe file. So it doesn't matter if you export a extension or interceptor, file extension will always be a .soe. And second part is, since I'm using an enterprise SDK to export my extension or interceptor, this file name without extension is always ends with _ent. But let's say if you are using ArcObjects SDK, in that case this file name without extension will not end with _ent. This is the difference which you have to note. Okay, so now I have written my code, I have exported my extension. The next step is to register this extension with ArcGIS server. So to do that, access your server manager, go to site, extension, add extension, browse to the SOE file you have exported, and click on add. Here, in the interest of time, I have already registered this extension with ArcGIS server, and I have also enabled it on my map service. To enable the extension on your map service, open your service, navigate to the capabilities section, and here you will find the separate interceptor section. You can use these left and right arrows for interceptor assignments. One important thing to note here is you can attach a multiple interceptors for a single map service. So in what will be the scenario for having multiple interceptors for single map service? Let's say one interceptor you want to use for your security and auditing purpose, whereas other interceptor you are using for executing your custom business logic. So this way you can chain your interceptors together, and you can toggle the sequence of the interceptors using this up and down arrow so that your request and response travels through the same sequence. Once you have selected the required interceptors, click on save and restart. Essentially what it will do is it will stop the map service and it will restart the map service with interceptors enabled on it. After this point, technically you can use this map service in any ArcGIS client and you will experience the same access control behavior. Okay, so this is the entire life cycle of server object interceptor. I have shown you how to create an interceptors, how to register, and how to enable it on a map service. Okay, now the last but important part is how to build interceptor. Being a developer, we always like to debug our code to make sure it works as expected. So in order to debug the interceptor or extension, you have to enable this debug setting. So access server manager, go to the site extension and click on this debug settings. Check this enable debugging of extension box, and same as this suspend service timeout. Okay, so as I explained before, the code in this init method will run only once, that is when service starts. Okay, so what this suspend service timeout will do is it will suspend once your service starts. It will give you a time to retrieve the service process where the Java debugger can be attached, and thus allowing you to hit the breakpoint if you have set any breakpoint in your init method. Okay, then you have to specify the range of open ports to use when attaching a debugger to a service. Make sure these ports are not in used, and here I am specifying this port range. Once your settings are done, just click on save, and again you have to click on save and restart. So how do you know or how you can retrieve the port number on which debugger can be attached? This is through server log. The moment you enable your debug settings, you click on save and restart your map service, you can query this information from the logs. So set your log filter to verbose and source as server framework and click on query. So here you will find the extension debug information that the Java debugger must connect to this process on port 6001. Okay, so now I know I have to attach my debugger to this particular port number. So I'll go back to my Java IDE. Just make sure I have put some breakpoints here. Then go to your debug configuration. Here I have already added one remote Java application, and I'm passing the exact port number. Okay, so just click on debug. Okay, so as I explained here, this function will get invoked whenever you access the REST map service. So let's access this map service request again. Let's say if I'm accessing this layer, as you can see, the debugger is hitting my breakpoint. Okay, so that way you can continue and debug your code depending upon your need. So this is all about debugging the extension debugging the extension code. Again, One important thing is enabling this debug setting is not recommended in production environment as it may impact your service performance. It's recommended only for your development or QA environment. Okay. Yeah, so this is pretty much about server object interceptor demo. It's quite long demo. Thanks for your patience. I'm handing it back over to Hanan for further part of the presentation.
Thank you, Pankaj. Now let's move on to our next topic, SOE, Server Object Extension. Let's see how an SOE works. This is the same server client diagram as before, and we can see no SOE is added yet. You may have noticed the only difference with this diagram is that I added a small icon here on the server object. This icon represents the service endpoints. The service endpoint is essentially the service URL that a client application can use to access the service. One service can have multiple service endpoints. These service endpoints can point to different resources and operations of the service, such as a query operation, export, map operation, identify operation, etc. And we can see the request comes to the server object through the service endpoint. Now, let's attach an SOE to this service. We can see this SOE also sits on the server side with the server object. We can also see this SOE exposes its own service endpoint, and accordingly, it creates new service operations. When the client application consumes this new service operation, it sends a request through the SOE's endpoint. The SOE will process this request based on the custom logic defined within the SOE, and at last, the SOE generates a response and sends it back to the client. So this process involves lots of customization done by the SOE. So first, a new service endpoint is defined by the SOE. And then, the type or format of the request parameters and response content are also defined by the SOE, so that the SOE can understand what types of requests it can accept and what kinds of response it's going to send back. And at last, the SOE also has its custom logic to execute based on those request parameters. So because of this, SOE requires a client application that is able to prepare the request and parse the response. Out-of-box ArcGIS client applications cannot interact with the SOE, and most of the time, client-side customization is needed. For example, if I have an SOE with a custom query function implemented, to consume this function from a client application, I cannot use ArcGIS Online Map Viewer or ArcGIS Pro, but I can develop a JavaScript application built with ArcGIS JavaScript API, or I can also consume the function of the SOE from an ArcGIS Pro add-in developed by Pro SDK. Another point I'd like to mention is that SOE will not change or affect existing service functions or service endpoints. It only adds new service endpoints on top of the existing service and adds additional functions without changing the default behavior of the service. Now, let's look at SOE's use case. Typically, SOE can be used to execute custom logic on a service, especially when the default service operation cannot satisfy your business needs. The most common use case for SOE is custom query functions, custom editing functions, and custom spatial analysis. Let me hand over this part to Pankaj again, and he will go into details.
Okay. Main goal of this demo is to show how to extend the capabilities of map service using server object extension. Here, I am using this vector data. Each polygon represents a certain kind of vegetation. My use case here is as a lumber or logging company that wants to know for a given area what are the different types of vegetation available. so that I can apply or dispatch a certain kind of logging or lumber operation. To do that, I have published this data as a map service using ArcGIS Pro, and this is my map service. Here, I have already authored one custom server object extension with my ArcGIS server, and same extension has been enabled on this map service. So if you scroll to the bottom, you will find supported extension section along with the extension name. So this extension is nothing but an additional capability of map service. Here, this extension implements one custom operation calculate area, and this operation has been implemented as a REST API. So before we talk about this REST API, let me show you one custom application which is already consuming the same map service and same extension. So this is a simple JavaScript application. Here user can specify a buffer distance in mile, and then user can click anywhere on the map. So basically it's returning the geometries of intersecting polygon within this buffered area. It also returns the list of unique vegetation types along with their intersecting area falling within this buffered area. Okay, so let's execute this REST API by passing the similar set of parameters. So this is my location, this is my distance. So this API has returned the geometries of intersecting polygon, and it has also returned me the unique vegetation type along with their intersecting area. So based on the distance specified by user and location where user has clicked on the map, this application has invoked a call to this REST API, and depending upon the output received from this REST API, or depending upon the response it has received from this REST API, it has rendered the output on the map. Simple. So consuming server object extensions in such an application is a better idea because your code or business logic runs on the server, which sits close to your database and can do computations much faster. Plus, it makes your client application lighter because your client application has to invoke only a one API call to serve the desired output. Correct? The next thing is, okay, this is my REST API. Technically, I can use this REST API in multiple custom applications who understand the REST. So to conclude, here in the form of an extension, we are exposing our custom business logic to multiple clients by adding new capability on the map service. And this capability can leverage on security and authentication features of this map service. Make sense? So now let me show you how I have developed the server object extension for this demo. I have installed Enterprise SDK on my machine. For this demo, I have used .NET with C# as my programming language. As I mentioned in previous demo, once you install Enterprise SDK, it configures the templates within Visual Studio. So here I am creating a new project in Visual Studio. You can see there are multiple templates configured. I'll pick this template because I'm interested in extending capabilities of map service published using ArcGIS Pro, and then just click on next. This will create a new project with custom extension class. So this is my pre-written code. I have started with the same template. As you can see, it has annotated as server object extension. Entry point is map server. This template provides lot of boilerplate code. Basically, it stubs out all the required functions for you. Okay, and then this is my custom extension class, and because it's a custom extension, I am free to choose any of these interfaces from the 4 interfaces I mentioned in previous demo. Here I have implemented IRS request handler interface because I want to make my extension available via REST API only. But if you want to use the same extension for SOAP API, then you have to implement iRequest handler interface and set this support SOAP to true. Okay. Then first thing here I do is create schema. So here I have defined a simple schema. It has one operation, calculate area. This schema accepts these two input parameters and support format type is JSON. So this is a simple schema, but in real application you can create a complex schema with the combination of resources and operations depending upon your need. Okay, and this particular operation implements one custom handler function. So this custom handler function is the place where your actual business logic gets executed. So navigate through this. Let's navigate through this custom handler function. So this custom handler function, depending upon the location, it's converting it into a ESRI geometry point object, and then it's calling one helper function to retrieve the results. So let's navigate through this helper function. This helper function is accepting ESRI point geometry and distance as input parameter. So depending upon these two input parameter, it's creating a buffer geometry. Then it's doing a special query to find out the intersecting polygon. Then it's looping through the each intersected polygon to clip the geometry of the polygon around the buffer area. And finally, it's calculating the unique vegetation types along with their aggregated area falling within the buffered area. Okay, and in the end, it's returning two JSON object, geometries of intersecting polygon and records for unique vegetation type along with the area. Okay, so that's all. This is what coding changes I did in this template. So essentially all I did is just defined my schema by adding one simple operations and implemented one custom handler function. I did not touch the other part of code in this template. Okay, so once your coding job is done, next step is to build this extension. So click on build. You can click build or rebuild. So the moment you build your extension okay, it creates one .soe file. Okay, and then the next step is to register this extension with ArcGIS server. So navigate to ArcGIS server manager, site extension section, add extension, choose file, browse to your SOE file and click on add. Here I have already added or registered this extension with my ArcGIS server. Then next step is to enable this extension on map service. The moment you register a new extension with ArcGIS server, you can straight away view it in under capabilities section of your map service. So here I am able to view my extension here, and this is the display name of my extension. Then how you enable extension is just check this extension if it's unchecked and click on save and restart. So this will stop your map service and restart the map service with extension enabled on it. Okay, so at this point you have a map service where extension is enabled. One important point to note here is this extension is using these properties. By passing this property, we are basically parameterizing our extension. So here it's using properties like layer name and field name. So let's say in future, if there is a change in schema of your underlying data, let's say there is a change in layer name or field name, in that case typically what you will do is you will republish the map service with the updated schema. Then during enabling this extension, all you have to do is just pass the updated layer name or field name here. Okay, so this is basically saving your work of again modifying your extension code, building the extension and re-registering with ArcGIS server. And this particular property page is rendered by ArcGIS server depending upon the properties mentioned in your code. So here I have defined the properties along with their default values. But if you are interested, you may register a custom HTML property page where you have an option of using rich controls like drop down list, radio buttons, etc. So we strongly recommend you to refer to custom HTML property page sample we have in SDK. Okay. So this is the complete life cycle of server object extension. I explained how to start creating server object extension, then how to build the extension, how to register with ArcGIS Server and enable it on Map Service. Now the last but most interesting part is how to debug the extensions in .NET. So whenever we create a service in ArcGIS Server, it's nothing but an ArcSoc process in the backend. If you see it in your task manager, you will find bunch of ArcSoc exes running. So to debug the extension, open your Visual Studio project, go to debug, attach to process. And then here I can directly attach my debugger to all ArcSoc process. But a smarter way to do that is you need to find out your service is running on exactly which process ID. So open your task manager, make sure you have added this command line column, then navigate through each ArcSoc exe. So here if you can see on your right hand side corner here in the D service, it's showing the service name. So I'm confirmed that my service is running on this 16084 process ID. Okay, so I will attach my debugger only to that process. So let me find out that process here. Yeah, this is my process and click on attach. Okay, so let me put some breakpoint to make sure it's hitting my breakpoint. Okay, then just let's invoke a REST API again. Okay, as you can see, it's hitting my breakpoint. Now I can step through the code or do the debugging of the code depending upon my need. So this is all about server object extension demo. I am handing it over back to Hanan for the remaining part of presentation. Thank you.
Thank you, Pankaj. So now, to summarize what we have learned about SOI and SOE so far, the main characteristic of SOI is that SOI changes the default behavior of existing service. The way to change the default behaviors is to modify the request and response. SOI does not generate any new service endpoints or service functions. On the contrary, SOE does not change the default behaviors of the service, but it creates new service endpoints and service functions, and these functions can be implemented either through REST or SOAP. In terms of SOIs, they can intercept REST, SOAP, and OGC requests. OGC requests are sent for WMS, WFS, and WCS services. Those services are service extensions of a map service, and other service extensions of a map service can also be intercepted by the SOI, such as feature service. And since SOI resides on the server object and does not change existing service functions, the client application will not know the existence of the SOI, and neither will it know what customization the SOI makes. So an SOI-enabled map service will just look the same as other map services without SOI added, which means it can work seamlessly with existing client applications. And on the other hand, for SOEs, because SOEs expose new service operations, we may need to customize our client applications to let it understand the new service functions provided by the SOE. Some of you may have already noticed this when Pankaj did the demos. Pankaj was using Enterprise SDK to build the SOI and SOE, but the code looks very similar to ArcObjects code. Actually, Enterprise SDK and ArcObjects SDK are two separate SDKs, but both can be used for SOI, SOE development. They have similar interfaces and classes. The major difference is that ArcObjects SDK is used to develop SOI and SOE for map services and image services which are published from ArcMap, whereas Enterprise SDK is used to develop SOI or SOE for map services published from ArcGIS Pro. So let's say If you publish a map service from ArcGIS Pro and you would like to attach an SOI or SOE to this service, you have to make sure your SOI or SOE is built with Enterprise SDK. And if it's built with ArcObjects SDK, then the SOI or SOE will not show up for this service. Another difference is the APIs that these two SDKs provide. ArcObjects API is a broad API for both SOI/SOE development and desktop customization. This includes ArcMap add-ins, ArcGIS engine controls, etc. So ArcObjects API contains lots of interfaces and classes that are not needed or supported for SOI or SOE, such as some UI elements and UI interfaces. On the other hand, Enterprise SDK provides a more focused API, especially for SOI and SOE development. The interfaces or classes that can't be applied in SOI or SOE are not included. From this perspective, the Enterprise SDK's API looks like a subset of the ArcObjects API. But these two APIs are distinct and different APIs, and they are not interchangeable. Before you start developing an SOI or SOE, you need to decide which SDK to use based on the platform which your service is published from. The last bullet point I'd like to highlight is code migration. Let's say you have an existing SOI or SOE built with ArcObjects SDK, and now you would like to convert this SOE or SOI to be used for a service published from ArcGIS Pro. In this situation, you will have to migrate your project to be built with Enterprise SDK. For a Java SOE or SOI project, this is simple. All you have to do is to replace your ArcObjects jar with the Enterprise SDK jar at your project's build path, and then recompile your project. But if you have a .NET project, you cannot migrate the code in a similar way. You will have to create a new project using the Enterprise SDK template, and then copy your code to the new project. The reason is that the .NET SOE or SOI template handles lots of project configuration information, and simply replacing the references will not make everything work. If you would like to read about more details, you can click the hyperlink on these slides for Java and .NET. The last topic I would like to talk about is road ahead for Enterprise SDK. We have both some short-term goals and long-term goals. Currently, we're working on two major projects or features. The first feature is Maven integration. Apache Maven is a software project management and comprehension tool. It provides an automation tool and framework to help with project build and management. The new feature we will have is to integrate our SDK tools into this Maven framework. So the Java SOI or SOE development process will follow the same Maven practice, which aligns better with industry standards for Java development. Another benefit with this Maven integration is that you can use any Java IDEs to develop SOI or SOE, as long as the IDE supports Maven framework. So basically, those popular Java IDEs like Eclipse, IntelliJ, NetBeans, etc. can all be used for SOI, SOE development. The second feature we will have is shared instance support. Shared instance is introduced at 10.7 for map services published from ArcGIS Pro. As I mentioned earlier, one service can have multiple service instances running, but when this service is configured for shared instance, it will share the same service instances with multiple other services, and they can share one or more service instances. This is very useful for services that are not frequently used, because it can save lots of memory usage and improve performance for ArcGIS Enterprise. Currently, SOI and SOE are not supported to use with a shared instance, but in the future, we will allow enabling SOI or SOE with services which are set to use shared instances. In terms of our long-term goals, we're actively working on improving the Enterprise SDK. In the future, we're planning to support interceptors for more services, such as image service, utility network service, hosted feature service, etc. And at the same time, we're also going to add more interfaces or classes in our API to help achieve more functions specific to those services. Another area we will work on is custom data integration. So basically, end users will be able to view custom data in ArcGIS Enterprise. If you are interested in some of the features I mentioned, or if you have more ideas that is not covered on our road ahead, feel free to contact us or make comments on GeoNet. Here are some resources that may help you build your own SOI, SOE, and configure your webhooks. And this concludes all of our topics today. Thank you very much for joining us today. We hope you find this session helpful. If you have any questions, feel free to comment under this video or at our Enterprise SDK GitHub repository. We will try our best to answer them. Goodbye.